Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 14 titled Blind SQL Injection with Time Delays and Information Retrieval. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Go down, select the learning path, select SQL injection, go down, select blind SQL injection, and we're covering lab number 4 in this section titled Blind SQL Injection with Time Delays and Information Retrieval. Alright, let's get started. This lab contains a blind SQL injection vulnerability. The application uses a tracking cookie for analytics and performs a SQL query containing the value of the submitted cookie. So we've got the vulnerable parameter, is the tracking cookie. The results of the SQL query are not returned, and the application does not respond any differently based on whether the query returns any rows or causes any error. So similar to the previous lab, because the results are not returned, we can't use union-based SQL injection, and because there's no difference between how it responds on whether the query returns any rows or not, we can't use any of the blind-based SQL injection techniques that we learned in the previous labs. However, since the query is executed synchronously, it is possible to trigger conditional time delays to infer information. Okay, so because the query is executed synchronously and it's possible to trigger conditional time delays, that means we can use a time-based SQL injection technique. Next, it says the database contains a different table called users with columns called username and password. You need to exploit the blind SQL injection vulnerability to find out the password of the administrator user. To solve the lab, log in as the administrator user. Okay, so we have a few angles over here. The first one is to exploit a time-based blind SQL injection to output the administrator password. The next one is to log in as the administrator user. Okay, let's access the lab. And this might take some time, so we'll create our analysis section. And we'll also open up Burp. So I'm going to use the professional version of Burp for this exercise because the intruder portion of that version is much faster than for the community edition. However, everything that I do in the professional edition, you should be able to do with the community edition. It's just going to take a much longer time to do than it would have if you use the professional edition. So hit next and then start Burp. Okay, let's make that smaller. Put it over here and then set our browser to send requests to Burp. So now when I hit home, it should send it to my proxy. And it did. So let's send that to repeater because we're going to be making a ton of requests. Set intercept to be off and we'll work from repeater. Okay, so the first thing we need to do is confirm that the parameter is vulnerable to SQL injection. And we learned how to do that in the previous lab. So we said it would be a single quote, concatenation, and then we'll use either select PG sleep, and then we'll make it sleep, let's say 10 seconds, and then comment out the rest of the query. So you could either do that or you could also just do PG sleep. That should work as well. So let's test it out and see if it takes at least 10 seconds to respond. If it does, that means we induced a time delay, which means that it's vulnerable to time-based SQL injection. So hit send, and it's waiting. And here we go. So you could see over here, it took a little over 10,000 milliseconds, so a little over 10 seconds. So we've confirmed that it's vulnerable to SQL injection. The next thing to do is to confirm that the user's table exists in the database. Okay, and the way we're going to do that is we're going to ask the application true and false questions. So we're going to ask the application, does the user's table exist in the database? If it does, then sleep 10 seconds. If it doesn't, then don't sleep 10 seconds. And so if the application sleeps 10 seconds, then we know that the question that we asked it is true. And to do that, we're going to use a technique that we used in previous labs. So let's copy all this. Okay, so let's say select case when 1 is equal to 1. That's our true use case. Then PG sleep 10 seconds, else we'll say PG sleep -1. So if you use a negative number, it just won't cause a delay at all. So when the use case is true, I want it to sleep 10 seconds, otherwise don't sleep at all. And because this is a subquery, we're going to have to put it into curly brackets, and this should work over here. So let's copy that, put it in repeater, Control U to URL encode it, and hit send. So this did not work because you could see over here, it only took 278 milliseconds, although the use case over here is true. So we did something wrong. And I'm realizing right now what we did wrong. So it's select case when the use case over here, then PG sleep 10 seconds, otherwise PG sleep -1, and you have to end it using the end keyword. So let's do that. Copy it, paste it into repeater. Control U to URL encode it, hit send, and here we go. It says it's waiting, which means that it slept 10 seconds. So the response time took a little over 10 seconds to execute. So we've got a valid query over here. Now let's try 1 is equal to 0. So what we did over here is 1 is equal to 0. This is a false use case, so this should output false, which means it should go to the else clause and it shouldn't sleep at all. So let's send that and confirm that that's true. And here we go. We get our request almost immediately. Perfect. So now we have a way to ask the application true and false questions. And we're going to do that by asking the application if the user's table exists in the database. So we're going to say, select the case when username is equal to administrator. And we'll say over here from the users table. So what we're doing over here is we're confirming that one, the users table exists, but we're also confirming that the administrator username exists in the users table. So if it sleeps 10 seconds, that means both of these conditions are true. If it doesn't sleep 10 seconds, that means they're false. So let's paste that, do Control U to URL encode it, hit send, and it's waiting, which is a good sign. That means that the user's table does exist, and the administrator user is a user in the users table. Okay, and again, it took a little over 10 seconds to execute, which means that we asked it a true use case. So the next thing we're going to do is enumerate the password. But to do that, we first have to enumerate the password length. And again, to do that, we're going to ask it a true or false use case. So we're going to say select the case when username is equal to administrator and the length of the password is bigger than 1. If both of these are true, then sleep 10 seconds. Otherwise, don't sleep at all. So let's copy that and paste it. Do Control U to URL encode it. Hit send. And it's waiting. So that means that the administrator user exists in the users table and the length of the password is bigger than 1. Okay, so again, it took a little over 10 seconds. So let's try 25 and see if that works. So that would be 25 over here. Hit send. And we get that response almost immediately, which means that the password length is bigger than 1 but less than 25. So what you could do is test each number manually. However, this might take some time, so I'm going to send it to Intruder and automate the task for me. So send to Intruder, go to positions, clear everything. The position that you're interested in is this one over here, so let's put it back at 1. Add it. And then in payloads, use numbers, and it's sequential, so from 1 to 25, because we know it's definitely not bigger than 25, and the step count is 1, so increment by 1 each time. And then in resource pool, we're going to remove that because we don't want it to use 10 concurrent threads, because it'll mess up with our time-based SQL injection. So it has to use 1 thread at a time. And I believe the way to do that is create new resource pool and set the maximum to be 1 thread and start a tag. So this is going to take some time because it will sleep 10 seconds each time until it reaches a false use case. And so I'm going to fast forward the video until it's done, and then we'll continue with the exercise. Okay, it's done. Let's click on columns and then click on response received. And here we go. So this gives us the response time. And you could see over here, it's all larger than 10 seconds. So we need to look for the instance where it's no longer larger than 10 seconds and it's at 20. Okay, so this tells us that when we set the length of the password is bigger than 19, it slept 10 seconds, which means that's true. But when we set is the length of the password bigger than 20, it didn't sleep 10 seconds, which means that this statement is false. And so the length of the password is exactly 20 characters. Okay, so now that we've enumerated the length of the password, we need to enumerate the password. So enumerate the administrator password. And we'll do that in the same fashion. So let's copy this. And we're going to ask username is equal to administrator and substring of the password 11. So the first character of the password is equal to A. If it's equal to A, then sleep 10 seconds. Otherwise, don't sleep at all. So let's close this, discard it, go back to repeater, and test this out. Control U to URL encode it, hit send, and we get the request almost immediately, which means that A is not the first character of the password. Now, I need to check all the alphanumeric characters until it actually sleeps for 10 seconds. Instead of doing this manually, we're going to do it again using Intruder. So right-click, send to Intruder. In Intruder, go to Positions, clear everything. Over here, I'm going to make it sleep 5 seconds instead of 10 because it's taking a really long time to complete this exercise. And then I'm going to add this as a variable, go to payloads, select brute forcer, and this allows us to brute force the alphanumeric characters. Minimum length is 1 and maximum length is 1 because I wanted to test out one parameter at a time, and then click on start attack. Okay, go to columns, response received. You could see over here the response is less than 10 seconds, so that's not our first character. Let's go down until we get a 10-second until we get a 5-second response actually, because we switched it up if I'm not wrong. Yep, we said sleep 5 seconds. Okay, so let's go back to the results. And you could see over here at Z, it slept 5 seconds. Same goes for 4, 2, 7, 6. And I think I know the issue over here. Let's go to resource pool. And yeah, we were doing 10 resources at 10 threads at a time, which is incorrect. And so we're going to get incorrect results. So we need to do it one thread at a time for it to work. So let's rerun this. So go to attack and then repeat. And then columns. Response received. And you'll notice over here the response is less than 10 seconds. So we're looking for something that is bigger than 10 seconds. And you can see it paused, which means we likely got it. And here we go. So again, I keep forgetting I put it to 5 instead of 10. So we're looking for something that is bigger than 5 seconds. And if you notice over here, this is the only one. And so the first character of the password is 1. Now I want to enumerate the second character and the third character and so on until I've enumerated all 20 characters. Instead of doing that in Intruder 20 times, what I'm going to do is close this, discard it, and discard this one as well. I believe I've done it multiple times. Go back to positions, clear it, and add 2 positions. So this one. So the character of the password and then the character that we want to try out. And we're going to use cluster bomb. In payloads for the first one, it's going to be numbers. And again, from 1 to 20 because we only have 20 characters. And we increment by 1 each time. And then for the second payload, it's going to be alphanumeric. So brute forcer, alphanumeric characters, and minimum length is 1, maximum length is 1. And here we go, we've got 720 requests. Let's go to resource pool, make sure it's 1 thread at a time, and then start attack. So this is going to take quite some time because we've got 720 requests. And so I'm going to fast forward the video until it's completed and then we'll continue with the exercise. And we're back. So it looks like it's going to finish soon. So let's click on columns, select response received so that we could see the response time. I wonder if there's a way to filter out on the response time. It doesn't look like it, so let's cancel this and just order by response time. So anything that took bigger than 5 seconds, that means it's a valid character. So for example, the 6th character of the password is O, the 16th character is D, and so on. So I'm going to see if I could maybe highlight these, and I should wait for it to finish, and it just did, because I want to be able to order them. Okay, so we've got 600, 500. Okay, and it looks like I got more results than I need, and that's not a good sign. Oh, and I didn't copy it correctly. All right, so let's highlight it. And here we go. So that's bigger than 5 seconds. Right click, highlight. Let's just say this, and then only show the highlighted items, apply. And I wonder if I can make this a color that is a little bit easier on the eyes, and I don't know how to do that. Okay, so it only does it for one of them. So let's maybe select everything again and change the color. Okay, let's go with yellow. Okay, so now let's order on the payload. Okay, so starting off with the first payload, we said the first character is 1, and then we're looking for the second character over here, so that's 3. And then the third character, I. Fourth character is P. Fifth character is N, O, B, 7, L, and then We're looking for character number 10. So that's 2. Number 11 is D, and then you've got K, J, P, 3, D, R, R, Y, and number 20, which is Y over here. Okay, let's highlight this, copy it, and see if we could log in to the administrator account using it. So, username is administrator, password, let's paste this, and hit login. And here we go. It says, congratulations, you solved the lab. Okay, so we successfully exploited a time-based blind SQL injection in order to output the password of the administrator user from the database using Burp Suite Professional. Now, if you don't have Burp Suite Professional, you could always script it with Python, which is what we're going to do right now. So first, let's save this. And then the first thing we do when it comes to our Python script is import our library. So we'll start out with the sys library, and then we'll import requests, URL lib3, and then URL lib. So we'll use all that in our script, and we'll add this line over here so that we don't get any warnings when it comes to certificates. So URL lib3 dot exceptions dot insecure request warning, and it does not have curly brackets. Next, let's set our proxies setting. So that would be HTTP, and then we'll also do it for HTTPS. Okay, so what that does is it ensures that anything in the script gets sent to Burp first and then to the application, and any response from the application gets sent to Burp and then to my script. And I do that because it helps me debug my script in case something is not working properly. It allows me to see the requests that the script is making. So the next thing we're going to do is call the main method. So that would be main. Next, let's define our main method. So the way I want to run my script is, as usual, it would be script.py, so the name of the script, and then it takes in the URL as the parameter. So if the length of the parameters is not equal to 2, so the name of the program and then the URL that we want to exploit, then I want it to print the usage instructions, so the name of the program and then URL. I also want it to print example instructions. So again, name of the program, and then the URL could be, for example, www.example.com, and again, name of the program. Okay, and because you didn't run the program correctly, I want to exit it. Alright, so assuming you ran the program correctly, I'm going to save the command line argument into a parameter called URL. Next, I'm going to print retrieving administrator password, and I'm going to retrieve the administrator password using the function SQLi password, and it takes in the URL. Alright, so what this function will do is it will exploit the time-based SQL injection and retrieve the administrator password. So let's implement this function over here. So SQLi password takes in the URL. I'm going to create a variable called password extracted. So this is the list of characters that we so far extracted from the password of the administrator. So it's empty at the beginning. And then I'm going to create my for loop. So for I in the range 1 to 21. So this will check the first character up to the 20th character. And then I'm going to say for J in range 32 to 126. And again, we've done this in previous labs, but if you haven't watched those videos, what I'm doing over here is just using the ASCII version of the character. So over here, you could see that the space character is represented by 32. And then you've got over here, for example, the capital A is represented by 65 and so on. And so instead of creating an array that contains all these characters, I'm just going to loop through the ASCII version of those characters. And I'm able to do that because there is an ASCII function in SQL that I can use in order to compare with the characters. Okay, so we start off at 32, which is this space, and then we move all the way to 126, which is this character over here. So it tries the case-sensitive characters and the numbers and then special characters. So we don't need this anymore. I'm going to close it. Okay, next we're going to set our SQL payload. And we'll get that from over here. So let's copy that. Put it in here. I'm going to move this so it says 10 seconds right now. This would be a variable. And same goes with this one over here. So we'll replace those with I and J. And what that means is for each character of the password, which is I over here, it'll try all the letters that we just saw in the ASCII table. It'll compare them. So in order to properly compare them, I mentioned something called an ASCII function. So we'll do that over here. So it would be ASCII and the substring function. All right, so what this does, the substring function extracts the character, ASCII function converts it to ASCII, and then it checks is it equal to this ASCII number over here. If it is, then sleep 10 seconds, otherwise don't sleep 10 seconds. All right, next we need to URL encode it. So let's make this a little bit smaller so that we could see more of the code. Here we go. So SQL payload encoded is equal to URL lib.parse.quote, and it's the SQL payload. Okay, and then we're going to set our cookies to be equal to the tracking ID cookie, which likely timed out right now, so I'm not going to copy it. But then we also have a second cookie. So if we look at burp and go back to repeater, you'll see over here we've got a tracking ID and a session cookie. So we'll add the session one. And again, because it likely timed out, I'm not going to copy it. We'll just load it again. Now for the tracking ID, we've got the tracking ID plus the SQL payload. So we'll add that over here. SQL payload encoded, and that looks good. And then we'll make our requests. So R is equal to request.get, and we're using the get method because it is a get method that is used in the request. So it takes in the URL, takes in the cookies. So cookies is equal to cookies. Set verified to be equal to false because we don't want to verify certificates. And then we'll set proxies to be equal to proxies so that the request gets sent to burp when the script is run. And then we're going to check if the elapsed time in seconds, if that's bigger than, let's say 9. So if it's 10 seconds or more, then password extracted is equal to whatever password extracted is currently plus the character. So that would be the character version of the ASCII number, so J. So what we're doing over here is we're just adding the character to the password extracted variable. And that's because it slept 10 seconds or more. And so that means that character is valid. All right. And then we want to output it to screen. And flush the screen. And we break. And the reason we break is we want to get out of this for loop, so the one for J, because if we found the character, we no longer need to try all the other characters because we've already discovered it. And so instead, it'll just move on to the next character. And that makes it a little bit more efficient than burp. Okay, otherwise, print out the character that you're trying on screen, but we're going to flush it afterwards because it's not the correct character. So password extracted plus character J, and then this dot std out dot flush. Okay, so what this should do is it'll output all the characters it's trying. Once it tries a character that actually requires the application to sleep for 10 seconds, that means we found a valid character. It'll put that on screen and then it'll move on to the other characters in the password. Okay, this looks good. Hopefully it doesn't have any errors. Now what's left is to get the tracking ID and the session. And to do that, let's see if this timed out. Did. So let's open a new session. In the meantime, let's save this. Select terminal, new terminal. And it would be Python 3, SQLi, lab 14.py, and then the URL. So we'll take the tracking ID from over here. And the session from the cookie editor as well. And I copied that twice. And what I'm going to do is I'm going to make it run for the first character only, see if it's working properly. If it is, I'll run it for all 20 characters. So let's copy this, put it in here. And that did not copy correctly. Okay, this should work. Hit enter and let's see if we have any errors. And we do. So that would be line number 8. And that should be a comma. Save it again, clear, and let's run it. And we get another error, and it's on line number 16. So we've got tracking ID and then session. That should be this over here. Save it, clear, and run it again. And we've got a lot of errors today. So number 25. And you could see it's because it's really late. So sys.stdout.flush. And over here, we're missing a curly bracket. So let's save. Hopefully that's the last error. And it's not. So number 38. And we're missing equal to signs. Okay, so it's not a good idea to be coding at 2 a.m. in the morning. Okay, here we go. It looks like it's working right now. So I'm going to fast forward the video until we've enumerated the first character, and then we'll do the other characters in the password. Okay, and we're back. So the first character is A. It looks like it's working properly. So I'm going to get it to enumerate all 20 characters. Let's clear this. And again, I'm going to fast forward the video so that you don't have to wait 10 minutes or whatever amount of time it takes to run the entire program. And we'll come back to it after it's done. Okay, and we're back again. It looks like I didn't save the script, and so it ran it only for the first character. So let's do that one more time, and hopefully this will be the last time. And it should enumerate all 20 characters right now. And again, we'll fast forward it until it's done. And we're back, so it looks like it completed. Let's copy that. Go to my account, For the username, use administrator. For the password, use the password we just enumerated. Hit login. And it says invalid username or password. It might be because I copied the space over here. So let's do that. Copy. And paste. And here we go. It says, congratulations, you solved the lab. Okay, to recap, we first exploited a time-based blind SQL injection using Burp Suite Professional, and then we scripted it using Python. In the next lab, we'll start looking at out-of-band SQL injection.